Welcome everyone to our webinar today. My name is Larry Pearson. I'm the Vice President of Marketing at Impetus Technologies, and I'll be your host and MC for today's session entitled A Cognitive Approach to Data Warehouse Modernization. During this webinar, we'll demonstrate a way to lift, shift, and modernize your data warehouse to a big data environment automagically, using what we believe to be the industry's first cognitive workload migration engine. And to defend our ability to make that statement, you'll see a pretty comprehensive agenda, including a live walkthrough of how that cognitive engine does work. It will be an interactive discussion followed by a Q&A. If you have questions, we ask you to not hold them to the end, that you can send them during the event itself using the panel there on the lower left-hand or right-hand corner of your display. And as I say, we'll attempt to answer all of those at the end of today's session, and those that we cannot, we'll be sure to answer on a follow-up via email. So without further delay, let me introduce our speakers for today. Vineet Tyagi is our CTO and Head of Innovation Labs at Impetus. Vineet has over 20 years of experience in product development and creating enterprise-grade solutions for the Fortune 1000. His area of expertise includes big data, advanced analytics, cloud computing, digital transformation, and cognitive engineering. He's led the R&D effort, which resulted in some of the best practices in the automation platform, which we're showing you today. He also has led through our R&D lab, what we call Impetus Innovation Labs, a number of open source contributions, and is a frequent and popular speaker at industry conferences. So some of you may be familiar with Vineet. He has been featured in some of our previous webinars as well. With him today is Dhirendra Sinha. Dhirendra is the product manager for workload migration at Impetus, and he's responsible for understanding customers' business challenges in the data warehouse modernization domain, mapping those requirements to our roadmap, and allowing us to provide a secure and scalable solution that leverages contemporary big data technologies. Extensive experience in those technologies and advanced analytics, as well as BI, Hadoop, relational database management systems, and machine learning. I'd like to introduce a poll right up front that will help set the stage for us and for all of you on who we have in our audience today. You'll see the poll question on the screen right now asking you to identify where you are at in your data warehouse modernization journey. Just a comment on terminology a little bit. You'll hear we're all pretty familiar with the acronym EDW. You'll hear us refer to BDW during this presentation. It's just like EDW as Enterprise Data Warehouse. We use that as a term to refer to the full spectrum of technologies that represent the big data platform environment today. As you're all well aware, Hadoop is now 10 years old. We actually got started under Vineet's leadership in our labs organization almost 10 years ago, working in Apache Hadoop. But in today's environment, big data analytics refers to more than just Hadoop. And in fact, when we use the term BDW, you'll also hear us refer to big data platforms or the big data environment. We really use that term generally to encompass not just on-prem Hadoop-like frameworks, but also hybrid frameworks with maybe a combination of on-prem plus various of the cloud-based platforms like S3 and also Spark. So you see here in the questions, we ask you to rate your progress in the journey from the enterprise data warehouse to the creation of a working big data warehouse environment. From stage 0, no modernization initiatives in place. Stage 1 says we've got early progress on a modernization initiative. Stage 2 says we're actively using Hadoop, Spark, or other big data platforms for big data analytics. And lastly, stage 3, our EDW exists and collaborates with our big data warehouse. What I'm going to do now is just spend a minute talking about the agenda for today's session. We will leave that poll open while I do that, and then we'll close the poll and give you a chance to see the feedback from our participants today. This is the outline that we have organized our material today around. Quite frankly, it represents our experience in developing best practices, in understanding the challenges that you all face, and developing automation accelerators and solutions that are proving to be very, very helpful. And all of this is the result of more than 20 different customer projects where we've helped large enterprises to take the next step in various aspects of their journey into big data analytics. So you'll see here that we are covering some of the major challenges as we see them, the what, why, and how of automated migration. We will talk about some actual impact and use cases from some of those experiences that we have, and then give you an actual automated workload migration in action, an exact demonstration of how the four-click paradigm actually works, and then we'll summarize and go to questions and answers at the end. So if we could close the poll at this time, and you'll see the results of that on your screen here. We'll give that just another minute here to close. And I'm actually not seeing, the poll has ended, and I'm not seeing the percentages here in response to the poll. There we go. Took a minute to tabulate that. You see that here with 1/4 of our audience, excuse me, 1/4 of our audience saying that they are at stage 0, and that 75% of the audience has started down that journey as at some point, with 1/4 saying we've just recently started, and about 1/3 saying we are actively using Hadoop, Spark, and other big data platforms. So that's very, very interesting. I'd like to turn the presentation over to Vineet. Vineet, you may also have some comments about the results you see here. There's one other statement here on the screen now. And the fact is, when we work with analysts, and we work with all of the leading analysts, the question I very often will ask them is, what are some of the questions you're most often asked by executives in the Fortune 1000? And very commonly, the answer that I'll hear is that we've spent a lot of money on our big data journey. We spent a lot of money on Hadoop, creating data lakes, doing proof of concepts, et cetera, but we're not sure we're getting all of the return on investment for those big data investments that we have been making. And what you'll see today is some of our answer to that is the fact that there is so much valuable data which still resides only in the enterprise data warehouse, has not been migrated to allow the big data platforms and tools to benefit from that. And some of the challenges that our customers and partners have faced in achieving that is one of the roadblocks to maximizing ROI on big data. And Vineet, I'm sure you, in your interaction with many of these large companies and seeing the large projects we've been involved with off and on during the last literally decade, I'd ask you to jump in now and comment further.
Thank you, Larry, and a very warm welcome to all of the attendees today. Thank you for joining us on this interesting topic of cognitive approaches to migration from enterprise data warehouses to a modern data warehouse. So, Larry, this is an interesting topic that as I speak with many of our customers, and we have done 20+ very large projects successfully of migrations from enterprise data warehouse to a modern data warehouse. This is a common problem and a challenge. How do you increase the ROI of the BI investments that is being made by the enterprises? It's important to understand why there is such a low ROI figure. 15% is tremendously low. That pretty much means that 85 cents on a dollar that is being spent on BI investment, which is being wasted. And there is a bunch of reasons because of which this is happening. Typically the information silos and the information flow that exists in the enterprise is limiting. So there's a large latency in when the enterprises actually acquire the data to when it becomes useful as insights. And that is leading to this low ROI. All of our customers that we work with, in the last 4 or 5 years, the common strategy towards increasing this ROI has been the introduction of the data lake or the enterprise data hub or logical data model paradigm, which is primarily built over the Hadoop infrastructure. Whether it's in-premise or on cloud, but Hadoop is becoming a de facto part of the big data infrastructure that is there. And a large number of our customers are doing that to create more capacity to handle larger varieties of data with a higher velocity and with larger volumes in a very cost-effective fashion. And as enterprises that we work with have successfully created this infrastructure, have started monetizing the data, which would mean that really driving insights from all these new sources of data, new types of data, and leading to revenue, actual revenue getting added to the top line. The reality is coming into the enterprise today that enterprises or the enterprise IT has a multi-platform data warehouse infrastructure. And that multi-platform data warehouse infrastructure includes the legacy, the not-so-legacy data marts and warehouses that power the insights and make them available for consumption, as well as the big data infrastructure and the big data warehouse that has come in. So between all these three, there is a multi-platform logical data warehouse infrastructure that the enterprise has to deal with. And within that, one of the largest challenge now the enterprises are facing is how do you right position the workloads in any of these platforms. And that requires migration, active migration. You would perhaps determine that certain workloads which were running on data, whether they were data preparation or some other characteristics of targeting them, but certain workloads which were running on, let's say, Teradata or Melissa infrastructure might be best from a price performance characteristics to run on the big data warehouse now, and that's leading the enterprise to actively now look at migrations. So when we go work with customers, current strategies for migrating is pretty much the de facto is manual. You plan a project, you figure out what you need to do, and then you actually plan a team, equip the team with the right tools, and create a program or a project plan, and then the team executes. What we've seen at manual migrations come with a lot of challenges. A lot of the analysts out there have done research, and in the last 4 or 5 years, as the manual migrations have happened, a lot of those migration projects have been failing, and they have failed to either achieve their objectives of migration itself, or they have failed and exceeded the budgets and schedules. So the fact that these were supposed to be projects which will increase the ROI are not delivering as they should be is further, kind of validated by the research that Blue Group has done. And they've gone into a little bit more insight that all these projects which are failing and running over time and over budget, they are doing so typically at the cost overruns are averaging around 30% plus. And from a schedule time perspective, they are, overrunning by an average of 41 or, 40-50%. So that's pretty scary. There is a high likelihood of failure. And even when you're succeeding, there is a high likelihood that you would be overrunning on your cost and overrunning on your time schedule also. So clearly something is not working, and there's a lot of challenges in this space. And as we work with customers, some of the challenges that we've found that they are getting limited by have been, if I broadly categorize them, have been in this area. Definitely, manual migration is a complicated process. It's extremely complicated to understand the data structures of the data mart. Sometimes there are no clear documentation. Things have been built over numerous years, and the residual knowledge doesn't exist in the enterprise. People who created it might have left. So trying to figure out what tables, what data, what queries, what constitute the workload, how it runs, how it affects the information plumbing within the organization, what are the pre-dependencies and what are the post-dependencies, how it gets consumed, etc., is a very complicated process. In many customers, we've seen that they don't even have an inventory of what is available. The inventory is the warehouse. You actually look at the warehouse, and whatever is running is the inventory. In one case, and I've seen this happen many a times, people don't even know what is running is actually getting used. So there are orphans consuming, precious CPU, precious I/O, and precious data, things that nobody knows why they are running and who's using them. So it's an extremely complicated scenario out there to unravel. Second largest challenge that we've seen is about people readiness. Manual migrations require that you have a highly skilled team of people who can take on big data migrations, who have the right expertise. And given the nature of big data technology, there's a lot of churn, there's a lot of uncertainty, there's a lot of new things that keep emerging. So there's not a lot of people who know or who have mastered or who have the right expertise in doing that. Manual migrations are time consuming, and inherently by nature, every migration that I've seen of any order of enterprise large magnitude happens to be a 40, 50, 30, 40, at least a few tens of people, and at least a few months, or typically around a year or so. So it's time consuming, and the fact that all of this is manual is risky. You are as good as your best people. Functional equivalence of what was migrated and recreated and semantically reconstructed. How do you certify that? How do you put that in production? How do you make sure data has made it over appropriately? And actually complicating this fact is also the technology readiness of the big data ecosystem. While it's getting strengthened, the enterprise data warehouse world, the Teradata, Netezza, and Oracle, and several of the SQL query engines were extremely strong. They have been battle tested for the last year, 33 decades or so. There's a high degree of compliance to ANSI SQL standards, and they have also extended and given a lot of facilities to keywords and other things that they have created. There is no equivalence of that on the big data world. So how do you actually migrate this becomes a very big challenge as well. So when we started working with a lot of our customers and we faced these challenges, and given, Larry, as you were talking about for the benefit of our audience, I recall at least 20, 25 customer stories, different unique customers where we ran into all these challenges. And we realized that manual migrations are the status quo. That's how things are done. But it clearly needs to be disrupted. There clearly has to be something better available and made available to the world so that people can cause ROI increases without having to invest so much through manual intervention. And that's when we, in our labs, ran some experiments and created certain approaches and figured out that there has to be a cognitive way of differentiating all of this. So what we've created is a cognitive, series of tooling, and we will actually present to you things as they work and details around how this whole approach works. But it's built on all of that, what we have learned, all of our repeatable methodologies, frameworks that we've created. And it is an amazing piece of engineering that we have created that really takes away all the pains of manual migration, addresses all these challenges, and creates a very high order of magnitude success for our customers. And before I invite Dhirendra and to walk us through some of these details and how this is done, I actually wanted to share that this is not the first time we've done it. We've actually been doing it over the last year, and several of our customers have benefited from this cognitive approach. And a few of them, while keeping the confidentiality of their names and what we did for them, some use cases I wanted to share with you all. There's a leading financial company, one of the giants and probably the biggest in the world. They realized that their big data ecosystem needs to now power or be the ground from which they will serve some of these insights and other things. And they were actually looking for migration on offloading of large amounts of their enterprise data warehouses to consolidate data and run these workloads from that consolidated enterprise data lake. And what they realized was there were extremely complicated PL SQL scripts. There were several PL SQL scripts which run into multiple pages of code, 20, 30, 40 pages of code. And not only that, there are thousands of them, tens of thousands of them. And they realized that, this is going to be an extremely risky process. It's complicated for them to even think about and plan a manual migration that can be possible and feasible to offload. So we worked with them, used our approach, and happy to report that we have worked out and we have demonstrated to them that they can automatically translate and migrate PL SQL scripts. We've also migrated some of the data preparation, data flow jobs on ab initio to the Hadoop ecosystem on Spark, etc. So this has been a clear value impact. So something that was complicated, was very risky, and was not manually possible was made possible through our cognitive approach. There's a leading telecom company that we work with, and this was a case where their primary, Teradata, which was their primary infrastructure for generating all the insights for their business, was choking on capacity. And what this means is that pretty much scaling the Teradata infrastructure to the level of what they were planning with hundreds of terabytes of data was a bottleneck. They couldn't even plan for that, and cost was a consideration. So they were looking for how can the big data infrastructure, the big data warehouse come in and take over some of the capacity of Teradata, what could be migrated. And folks, I'm talking about an extremely complicated data warehouse which is, hundreds of terabytes and built over decades of experience, and nobody knows what is in there and how would you actually, which ones are the workloads you would migrate and how would you free up in an orderly fashion 40% of the Teradata capacity. So our cognitive engine went in there, we did the full assessment, the full inventorying, and we solved this problem. So we de-risked them, and the impact that they were able to see was that we were able to offer them a clear roadmap and a pathway and convert it into a data-driven decision-making as to how they can benefit from this. Another multinational US retailer wanted to optimize their data warehouse infrastructure, and the challenge there was that, again, it was built over several tens of years, and nobody knew what was happening. There was no documentation. The databases were there, but there was no information available around what is being used and what is not being used. So again, we went in, created the whole assessment through the cognitive engine, understood the semantics of what the queries are doing, how they're getting used, and then optimized and created a roadmap where Teradata EDW was optimized over to Hadoop. The last use case I want to share for today before we move on to the section with Dhirendra is a leading broadcasting company in the US. And they had already, before we started working with them, they had created their roadmap and they knew that they had to do this. They had planned out a 40-50% team for a year plus to do the migration. And when they heard about our solution, we started working with them. The impact that we delivered was what was planned to take 40-50 people and a year or more could be delivered in days and weeks with a team which was less than 10 people. So that was a tremendous cost saving and an acceleration that was delivered through our automation of the Teradata BTech and the automated migration. So now I've talked about some of these customer impact that we are creating with this cognitive approach and our tooling that we've created. And I must be leaving you all wondering what this, Automagically thing is, and you really want to know some more about it. So with that, Dhiren, I would invite you now to really share a lot more details about our cognitive approach and how we do that and demonstrate some of that for our audience today.
Thank you, Vineet. Once again, a very warm welcome to our audience who have joined us today from different parts of the globe and are watching us live. Also, thank you, Larry and Vineet, for setting up the context and emphasizing the importance of moving to a big data environment. I think it is pretty important for all of us to understand the challenges of manual migration, and I'm assuming that many of you may have been struggling with it too. But trust me, folks, mitigating these challenges and achieving customer success is never an easy task. So the important question is how we have been able to deliver where others have not been able to get success. So this is where our cognitive workload migration tool comes into picture, which lifts, shifts, and transforms your data warehouse automatically to big data. Folks, we all are aware that migration is not a single step. It's an entire journey. And Impetus, with its extensive experience in migrating large data warehouses, has simplified this daunting task of warehouse modernization through a 4-click paradigm. Now, let me quickly introduce you to this 4-click paradigm, which takes you from zero to big data platform in just 4 simple steps, which is assess, migrate, validate, and execute. Let me talk about the first step over here, which is assess or assessment, where our cognitive engine automatically profiles the current workload, identifying the patterns, and recommends the offloadable queries and entities. The second is migrate. In this step, the actual shifting of your data, metadata, and other entities happens. Here it takes the information, or I would rather say the recommendation that was generated from the assessment done by our cognitive engine, and migrate the entity. The next step is validate, where we ensure the metadata and data equivalence between the source and the target. And the last step is execute, which executes the transform scripts onto big data platform and loads your prepared data back to the EDW for reporting purposes. Now, folks, this is a slide which many of our customers find pretty interesting. As you can see in this slide, all the processes which I was talking a couple of minutes back is backed by a cognitive engine which sits in the middle and takes input as query log and scripts and provide recommendation on the workload which are to be migrated. And it auto generates the workflow for migration as well. It migrates the data, schema, views, and the intelligent translation engine which we have developed automatically translates the legacy code to big data compatible scripts. It also ensures that the role-based access control and reports are migrated. And this is how the cognitive engine takes care of the migration process seamlessly.
Thank you, Dhiren. Very, very helpful. I'd like to pause at this time and take a second poll. This particular poll actually has 2 different questions. You should see that running on your screen right now. Which of these EDW workloads would you like to offload to a big data environment? You can choose one or more. You see those listed there, what I kind of refer to as the usual suspects. And the second question is, which is your preferred query engine for migration, Hive, Spark, or other? And you can choose one or more of these, and we'll let that run for a little bit here and get your feedback there. This is also another good time to remind you about the Q&A. So as you have questions, be sure to send those through, and at the end of our webinar today, we will address those. So we'll let that poll run for a few more minutes, a few more seconds rather, not minutes, and give you a chance to answer both questions, and then we'll go ahead and summarize the results of that. So if we could, Ops team, if we could close the poll now and summarize the results for our audience. It'll take a minute for us to do that. You'll see that come up on your screen. And as I say, it'll take a minute to do that. There you go. So if we look here under question number 1, which of the current EDW workloads, you see Oracle. Almost half of you have an interest in migrating Oracle-based workloads. The second most popular is actually a tie between both Teradata and SQL Server, followed by some of the unidentified RDBMS systems or appliance-based systems. Netezza, as you see here, almost 1 out of 10 have an interest in migrating some of the Netezza workloads. As far as the intended target environments, Spark is the clear winner, with almost 3/4 of the participants saying even if we end up wanting to utilize multiple query engines in the big data environment, almost 3/4 see some role for Spark to play. And frankly, I, along with you, are probably not surprised at that based on the conversations we're having with all of you. So, Duran, back over to you to show us then how it is that we deliver that simplified acceleration for people wanting to migrate these types of workloads.
Thank you, Larry. So, yeah, here what you see is a traditional EDW architecture where data comes from disparate sources, and after the ETL is performed, data is stored in EDW, which is used for reporting. And if you look at this slide, this is an architecture of the Impetus workload migration tool, where the entire EDW will be migrated to big data environment using various transformations. Now, let me show you how the workload migration solution works. So let's get started. But before I start demonstrating the solution live in action, here is an EDW report which I want to show and take a minute to describe it. So as you see, this is an EDW report which is comprehensive and is quite critical for business users, as it provides important decision-making information. If you look at this report, it is a sales report that provides summary of sporting goods sales for a US company in 2016. In this slide, you can see the Teradata query which is used to extract this report. Here I have intentionally used this query as this contains custom UDS as well. As you will see, I'll be translating this custom UDS. By the way, just to let all the audiences know, this report takes high execution time and is pretty resource intensive as well. And we are not talking of a single report over here. In fact, there are typically many such reports when we talk of EDW. There may be 5,000 or 10,000, and it is quite tedious to identify all of them. And there can be a lot of other entities which needs to be migrated, like tables, views, scripts, and many more. So let's have a look at our first step, assess, or as we call it, a cognitive analyzer of a workload. In this, I'll be uploading our extracted query log, and our application will identify the pattern and will suggest the workload that can be migrated. So after this, the engine provides you with detailed recommendation on several query engine types, query construct, recommendation on the suitable query engine for execution, and once user is satisfied with all this recommendation, it can offload with just one click. At this point, I have done a lot of explanation, so let me quickly jump onto the application and show you the real intelligence and power of workload migration tool. So immediately after you log into the application, what you see is this page. But for now, let me quickly create a fresh assessment for you. So I'll click on this Create Assessment, provide PD, name to my assessment. So TD offload Spark. To quickly start, we have a query-generated CSV file which contains all the resource-intensive and low-performing queries. But there are a couple of other options as well. You can directly connect your database with the application or can provide the DML scripts as well. So let me select this offline query log option for this demo. Click on Next. So this is the configuration page where we need to select the EDW type. For this demo, I would be selecting Teradata. Then upload my CSV file. So I'll be uploading my CSV file over here. Click on Next. Now on this page, you see several thresholds over here. So these thresholds are there to baseline the recommendation of ideal migration candidate. So let me select the default preset over here. Save my assessment. So my assessment is getting created now. And once it is created, I need to execute this one. While the assessment is getting created, let me give our audiences some quick pointers, I would say. You can set up your desired mail ID to be used during the assessment, and you will be getting notified via email once your assessment is ready. So there is an automated notification which will be sent across to your email ID, whatever you will be providing in the assessment stage. Also, you can choose to change the preset based on the requirement to get the ideal recommendation candidate, which I showed to you. And my assessment has succeeded. I can see a tick mark over here. So let me click on this. So here is our assessment dashboard. What you see over here is that application has analyzed the uploaded query log and has provided us some crucial and relevant information about the current workload. So as you see, there were some 15,000 queries, out of which 5,000 were unique. It profiled the different entities, it profiled the different query types, select, insert, update, and different query types over there. Then it profiled the query constructs as well, highlighting the order by, group by, and join condition. Below it, you can see several important and useful graphs. The last two depict the application-wise and user-wise resource utilization, and the first to provide information on daily memory and processor utilization. So this information is extremely useful to help you understand how your platform has been utilized. Further on the recommendation side, when you come over here, you can see that the system has prescribed to offload 5,000 queries and close to 118 tables that needs to be migrated to the big data environment. So let's drill down further to see granular details on the recommended queries. So let me click on this. So this depicts the distribution of these queries based on different parameters like CPU utilization, IO utilization. So this is application-wide distribution. Then we have user-wise distribution as well. You can see Mark is the guy who is running most of the queries over here. Now let me tell my audiences that every time I use this tool, I get extremely excited to see the kind of data and recommendation that I get from the uploaded logs and queries. So here you can also have see stats around each unique query. So let me click on this and you will see stats for each unique query. So you can just scroll over to see all the queries which you are having. So let me quickly go to the tables tab. And this gives stats around the table which are supposed to be uploaded. You can always sort by the frequency and can see what are all the tables that have been used quite readily over here. Then we have the query engine section. And based on the analysis of the query, the cognitive engine has recommended that almost all the queries can be transformed to Hive, except a few that can be transformed to Spark as well. So quickly moving ahead, we have the application-wise recommendation summary over here. Now let me go straight to the analysis tab to show you the in-depth analysis. So I'll click on this analysis tab. This shows you the application-wise resource utilization. Now data is represented in both data grid format as well as in graphical format to you. So you can just toggle to see the same information in form of intuitive graphs. And let me go to the Users tab now. The interesting part is you can see the resource utilization for each of the users who are there currently on your system. Then we have tabs around the queries which have been analyzed, the tables which the system has analyzed. Again, based on the frequency of use, you can always sort it out. The different statement types that the system has analyzed, and also stats for the different query constructs which are there. So I would say in a nutshell, the assessment provides a complete synopsis of your current workload. Now let me edit my assessment in order to reduce the number of queries for migration. I will edit and choose the preset which will provide me with the long running query. So I'll go on this, click on edit, click on next. Now I will select the store sales preset which will give me all the long running queries which are there in the system. Now once my assessment is created, I need to rerun it again. So again, it is analyzing the query log which is there in the system right now, and this has succeeded. And we can see there is only one query which the system is recommending to offload. So let's just have a quick look at this query which the system is recommending to offload. And here we can see this is the same query which is used in the EDW report which I showed you a couple of minutes back. And now I will migrate this to BDW. So if you are fully satisfied with the assessment like I am right now, my application will automatically create my migration pipeline which will be executed. So there are a couple of options over here. You can email this report on any mail ID if you want to. You can download this report as PDF for your offline analysis. You can migrate this report with clicking over here. So let me just select the source and target from this. So I'll select Teradata as my repository. Select the repository over here, the data source. Then I'll select the target. So I'm choosing Spark over here instead of Hive for this demo. Then repository as sales data mart. Spark sales data mart DS as the data source. And click on migration. Now my migration pipeline will be automatically generated, and there is a notification which you can see. So I just need to go to the pipeline tab over here. And here you can see that the system has automatically generated my migration pipeline. So before I go ahead and show you other steps, Vineet, why don't you share the impacts that we have delivered for our customers using our innovative cognitive assessment engine?
Yes, Darren. So a large part of what we do with our customers require any manual migration project or any migration project, if you take a look at it, requires that it needs proper planning and it be best planned with a lot of data. And in a migration project, there is a lot of different things that exist, and all of that has to be understood. There are query logs, there are queries, there are hot and cold data sets, there are usage patterns, how queries are being run or what timing or workloads, the trend of when workload run, SLAs, many other, such data points and sources of information. This coupled with the fact that, the big data warehouses or the whole big data ecosystem query engines which you intend to run these on are very different. We've seen that customers struggle a lot in trying to even inventory what exists and trying to then make a sense of it. So the biggest impact that I see this cognition engine driven assessment creating is that things which takes weeks and months of effort and pre-planning that goes into creating a successful migration now can be done based on the best practices that we have codified into the engine, the algorithms that we've created for analyzing these different data sets, recognition of the patterns, how queries will get converted, identifying those semantics of the queries, identifying what remediation needs to be done, and then recommending all of that through this intuitive UI that was simply shown. So really, I mean, Dhiren, you ran through all of such a complicated process in the last 10 minutes. And that's the biggest impact of what we bring to the table, and our customers recognize a true value of our tooling is.
Thank you, Vineet, for sharing such important insight. Moving ahead, our next step is migrate. Now, this is a very important step where we will be actually migrating the data, schema, views, and RBACs as well. There is built-in intelligence of the solution that it recommends you the optimized data model on the fly, and the logic translation engine automatically translates our legacy code. We migrate the data store specific custom UDF as well, like I showed you in my query which was there. And just to highlight, we support in-premise as well as cloud platforms. And using this tool, we are able to achieve more than 80% automated translation, which Vineet also highlighted in some of the client engagement which he was talking about. And for the queries which still requires any manual intervention, you have the flexibility to edit the query in a live interface. And moreover, all these translated scripts are completely standard and non-proprietary. So let's move ahead and look at our other steps, which is validate and execute. So in validation, we establish the equivalence between EDW and BDW for the migrated entities and the executed scripts. You can set up generic as well as table-specific validation at this point. So when we talk of generic validation, so this will be applied on all the entities which you are planning to migrate. And then there are table-specific validation which you can create on your own, which users can create their own query and apply it on any entity. We support HighQL as well as Spark SQL, and you can run the executed query on the query engine of your choice. Maybe High, maybe Spark, and once again you can validate it after execution of the script. And finally, from the audit perspective, we do keep an audit log of all the changes which are done in the system and do keep a track of the lineage of the pipeline created as well. Now, in the interest of time, I already have a pre-run pipeline which is having the same configuration as my auto-generated pipeline, which I'll show to our audience. So let me quickly go to my application once again. Now, this is my pre-run pipeline. I'll click on history of this Teradata Spark migration. Let me close and come over here again. Yeah, so here you can see there are different stages which are configured already: migration, transformation, and execution. So let me start with migration first. So you can see double clicking on this, the report which is there for migration. So all these tables which were used in my query has been migrated to the big data environment, store sales, item, and date name. We can go ahead and see the table specific validation which have been successful over here. Then moving ahead to the transformation part, you can see that the candidate query which we were having has been transformed successfully. And this is the original query which you are having over here. And this is the transform query section. So it transformed the custom UDF as well. It has taken care of the custom UDF as well. You can see a check mark over here that has been auto-transformed. No manual intervention is required. If at all any manual intervention is required, you will get the edit query option over here in the interface itself. Now let me quickly go to execution. So we can see that this has been executed successfully onto the big data environment. And this is how we transform the resource-intensive and low-performing EDW report onto the big data platform. Now I'll flip it over to Larry for further discussion.
Thank you, Vineet and Dhiren, for that interesting run-through. Again, now is a great time to begin to tee up your questions, and we'll take those here shortly. I want to take a minute, though, and summarize what it is that we've covered today. The Impetus Workload Migration Solution is designed to simplify and accelerate your migration effort. We do that through automated profiling and data-driven assessment, basically using a cognitive approach to develop a roadmap and a blueprint for taking you from your current environment into a transformed or modernized experience. The key to that is the cognitive translation engine, which you've now seen operating in action. It literally represents years of R&D and effort and continuous improvement by us to attempt to address what we saw as the primary challenges in the EDW to BDW journey. You saw that you have the flexibility to choose a target engine of your choice. It also optimizes the data model to be used in the big data environment. And finally, we have a complete, from the standpoint of data quality and assuring that the migration has been successful, we have a complete validation framework library, which you can take advantage of on an automated basis as well. The bottom line on all of this, as you see depicted here, we're talking about 5 times productivity, 1/4 of the time of a manual migration, and over 300% return on investment using automated approaches. So I want to thank our audience for being here today. We do want to move now to the question and answer session portion of our webinar. You will also see a pop-up for rating your overall experience with the webinar today, and you also have a place there to give us some comments and feedback on that experience. But without further delay, I'd like to move into the question and answer session. And the first question that we have here is, and Vineet, I'll ask you to take the lead for these, is why is this called cognitive? What part is using machine learning algorithms? So do the algorithms do the analytics on the CSV data to make recommendations? And could you elaborate all of that? And Vineet, I'd ask you to jump in and address that.
Right, great question again. So why is it called cognitive? I think the keyword or what cognitive is all about is understanding or creating knowledge from a wide variety of information. And generating that knowledge, itself from the wide variety of information here would be the sense that we make out of all these disparate sources of information, query logs, DML queries itself, patterns of the queries, the semantic of the SQL language, understanding the usage patterns based on the SLAs and CPU utilization, and several other parameters and data points that we analyze. We do use a lot of techniques, including variety of pattern matching, pattern recognition, clustering, classification, and other techniques, which obviously is a secret sauce, and I can't go into the details about how we actually do it without giving away a lot of our details about our IP. But yes, we do use a lot of algorithms on the CSV data. The data that Dhiren showed you and used was a real-time data set that came from real-time queries and the query logs, and it contained the DMLs, etc. So we do the analytics on the data set which is there. That's our primary input. And we also used other lexical analyzers to understand the semantics of the SQL queries, etc., to really figure out what needs to be done and understand the semantics and the semantic usage of that query as well. We also use techniques and algorithms, some of which are machine learning driven, to understand the recommendations or to create the recommendations based on the weightages which Dhiren demonstrated were created during the configuration page. So that are also evaluated and used for recommendations.
Great. Thank you, Vineet. Several other questions have come in. One of them, and actually several of you have asked, how could I get a trial on this? What's the way to start? And frankly, all of the projects that we've done start the same place, and that's with some type of a pilot on the assessment phase. And since that allows you to take a look at identifying migration candidates, gives you a feeling for what that roadmap or blueprint may look like, that's the place to start. If you look on your screen right now, you'll see the email address bigdata@impetus.com. In addition, I would encourage you to visit our website where we have other information laid out. We have a data sheet for workload migration. You also have a link there to communicate with us and indicate your readiness for starting a pilot. And so that's how that works. And it's, as I say, all of these pilots start that way, and we have a structured methodology for also gathering the requirements, setting up to run a pilot on the assessment, and so forth. I think you'd be pretty pleased with the best practices that we're able to bring to that as well. There's a question here that says, what is in the CSV file? Is that something you'd like to, Durenda, would you like to address that?
Yeah,
or do you want to jump in? What exactly needs to be in the CSV file, in other words, to drive this process?
Exactly, Larry. I think I would be taking this one, Larry. So the CSV file contains all the query logs which are there. So this is something we provide a script which you can run on your system, and the query will extract all the information in terms of a CSV file, which we finally upload in the application, which is analyzed by our application.
Okay, great. We're at 57 minutes after the hour. I've got time probably for one more question, and would again ask you to please not fail to give us feedback and rate your experience today. Very, very important to us. There's a question that just came in. It said, is it useful for user experience data in telecom and for the AI part? And Vineet, maybe you want to step up and to that one. Obviously, we have a lot of experience working with our telco customers.
Sure, Larry, and probably I'm not able to understand this question exactly, but I'll answer it from what I understand. So one of our audience is asking, how can some of these techniques and what can we do with user experience data in telecom? If you're capturing this data, let's say in a data warehouse which is currently running on Netezza or Teradata or Oracle warehouse, where you actually ingest this data, prepare this, and then run some algorithms or create insights out of it, our solution can help you offload it, in a fast and rapid fashion over to Hadoop. And once you get it over to Hadoop, you can do much deeper AI and mix it around with different data sets and run different kind of algorithms on a larger variety of data sets with it. So I hope I answered that question, but it was not very clear what the question was, and if still there is some follow-up, please write into us, and we'll be happy to set up a conversation or take a follow-on to your question.
Thank you, Vineet. Thank you, Durendra. Thank you all for joining us today. There will be a recording of this webinar available on our website beginning tomorrow. If you have teammates who were not able to attend today but you'd like them to benefit from this, we'd encourage you to use that archive. We also, at the end of November, for those of you who are in the Dallas-Fort Worth area, will be participating in the Evanta CDO Summit. And if you want information about that, you can ask about that also by writing to bigdata@impetus.com, and we'll follow up with you. But again, thank you all today. Thank you to our presenters, and have a great remainder of your day. This concludes our webinar.